So now I'm going to go over the answers to the calculation practice. So regardless of which one or ones you chose, I'm going to suggest that you go through these and write down some of the answers here so that you have the benefit of having gone through all of them. So on page 16, problem number 11, 30 years ago, police would check a highway for speeders by sending a helicopter up in the air and observing the time it would take for a car to travel between two wide lanes placed 1/10 of a mile apart. On one occasion, a car was observed to take 7.2 seconds to travel this distance. So how much time did it take the car to travel a distance in hours? So there are 60 seconds in a minute and 60 minutes in an hour. So 7.2 seconds is equivalent to 0.0020 hours. So that is 7.2 divided by 60 and then divided by 60 again. So what is the average speed of the car in miles per hour? So the distance is 0.1 miles, as it says 1/10 of a mile, and you divide that by 0.002 hours, and you end up with 50 miles per hour. So apparently the car was not speeding. Number 12, the fastest trains are magnetically levitated above the rails to avoid friction and are therefore called maglev trains. Isn't that kind of neat? The fastest trains travel about 155 miles in half an hour. So what is their average speed in miles per hour? So the distance is 155 miles, the time is 0.5 hours, so the average speed is 155 divided by 0.5, and you get 310 miles per hour. Number 13. In 1960, U.S. Air Force Captain Joseph Kittinger broke the records for both the fastest and the longest skydive. He fell an amazing 19.5 miles. Cool fact, there's almost no air at that altitude, and he said that he almost didn't feel like he was falling because there was no whistling from the wind or movement of his clothing through the air. And the temperature at that altitude was 36 degrees Fahrenheit below zero. So his average speed while falling was 250 miles per hour. How much time did the dive last? So the average speed equation needs to be arranged for time, and that is distance divided by speed. So we know that it was 19.5 miles and 254 miles per hour. So plugging those into the equation, we get 0.0768 hours, which is approximately 4.6 minutes. Number 14, a hummingbird averages a speed of about 28 miles per hour. Cool fact, they visit up to 1,000 flowers per day and reach a maximum speed while diving of up to 100 miles an hour. Ruby-throated hummingbirds take a 2,000-mile journey when they migrate, including a nonstop trip across the Gulf of Mexico in which they fly for 18 hours straight. That seems like a really long time. So how far is the trip across the Gulf of Mexico? So this time we want to find the distance. So rearranging our average speed equation, we get distance equals speed times time. So 28 miles per hour times 18 hours gives us 504 miles. That is a fairly long trip to go for 18 hours. So that is page 16. So page 18, the formula for calculating speed is distance divided by time. So you're going to want to color in that one, those areas yellow. Formula for calculating distance, it's speed times time. Formulator for calculating time is distance divided by speed. It takes 7.5 hours for a Galapagos giant tortoise to travel 1.5 miles. What is the speed of the tortoise? So you're going to take 1.5 divided by 7.5, you'll get miles per hour, 0.2. Ostrich is the fastest animal on two legs. Speed, what is the speed of the ostrich that sprints 10 meters in half a second? So that would be 20 meters per second. 6, Usain Bolt is the world's fastest man. How long does it take him to travel 100 meters if his speed is 12.4 meters per second? So in this case, we are looking for time. So time is distance divided by speed, and you're going to get 8 seconds. Elephant has a speed of 11.2 meters per second. What is the distance he travels in 60 seconds? So again, you're going to solve for distance. You're going to get 672 meters. The kangaroo travels at 20 meters per second. How long will it take the kangaroo to travel 27 meters? So this time you're looking for time. and you're going to get 1.35 seconds. Number 9, it takes a snail 80 hours to travel 0.5 miles. What is the speed of the snail? And they've got it, so it's 0.5 divided by 80. Number 10, a lion sprints after a giraffe. The lion's speed is 22.4 meters per second. How far will the lion get in 15 seconds? So we're going to be solving for distance. And we're going to be multiplying speed times time and get 336 meters. And then number 11, a chicken is traveling at a speed of 9.3 miles per hour. How far does it get in 30 minutes? So we're going to be looking at the distance and noticing that this is half an hour. Then sloths only leave their tree to poop. If a sloth is traveling at a top speed of 0.067 meters per second, how long does it take the sloth to travel a 11.5 meter tree? So this is going to be time, and we end up getting 2.86 minutes. And at the bottom here, it says use the table below to rank the order of the animals discussed in the assignment from fastest to slowest. Use miles per hour. Don't forget to solve for the speed of the cheetah, which is on the bottom of the coloring page. And the cheetah is going to be the fastest. And then it goes through here the speeds of everything else. And this is kind of what your cheetah looks like. And in here, the cheetah is known for being extremely fast. A cheetah can run 1 meter in that amount of seconds. How fast is the cheetah in miles per hour? And they give you the conversion here. So you end up with about 64.5 miles per hour. So then I have page 19. We have a rabbit runs 30 meters in 2 seconds. What's the average speed of the rabbit? So speed equals distance divided by time. We get 15 meters per second. Number 2, an object moves 50 feet in 15 seconds. Average speed is 50 feet divided by 15 seconds, and we get 3.3 feet per second. If an object's speed is 15 meters per second, how long will it take for it to travel 1.5 meters? So this, we've got distance divided by velocity, so 1.4 meters divided by 15 meters per second. Your units cancel, you're left with seconds. You get 0.093 seconds. While on a car trip, you average 43 miles per hour. How long will it take you to travel 500 miles? Again, 500 miles divided by 43 miles per hour, and you get 11.6 hours. Number 5, how far will a ball travel in 12.5 seconds if it has an average speed of 7 meters per second? So we have 7 meters per second times 12.5 seconds. You get 87.5 meters. And number 6, how far will a car travel in 1.5 hours if it has an average speed of 35 miles per hour? So we're multiplying speed times time, and we've got 35 miles times 1.5, we get 52.5 miles. So it's good practice for you to have looked at all of these and check through any that don't make sense. If you have any questions on them, please be sure to include those questions on your surveys. So some additional resources for you to take a look at are a reading on Google Classroom as well, on Physics Classroom. And in your textbook, I've only covered sections 2 and 3 in this. But if you find that you want just a little bit more to take a look at, those are 2 resources that might be useful to you. And now it's time to work on the last section of your MOP app. And this is KC6, which is average speed computation. So it's going to be calculations just like you've just been doing. And when you're comfortable, you're going to take the assessment for this section about speed and velocity. And after that, we're going to be ready for your Chapter 2 test. So email me with questions on your MOP app, or if you have any concerns as you're getting ready to prepare for your assessment. And then I will be back with you when it's time for you to take your Chapter 2 test.